We're going to continue with section 1.5. Okay. First thing are relative minimum and maximum. Okay. It's exactly what it sounds like. Okay. A maximum, you think of a high value. A minimum, you think of a low value. So when we're looking at a graph, when we talk about a relative minimum or maximum, then we're looking at where we switch directions, because then we have, a high, if we're switching from increasing to decreasing, we have a high point in our graph. If we're switching from decreasing to increasing, we have a low point in our graph. Now, this is something that we can do, but it's not always accurate. Calculus will help us become more accurate with finding minimums and maximums. Okay? So here is the function that we're going to look at. All right? Do you see a point where we switch from increasing to decreasing? Yes, okay. Right here, we would call this a relative maximum. Where does it look like it is as for the x-coordinate? Negative 2, okay. So it looks like it's at negative 2. How would I figure out the y-coordinate? Well, we could probably look at it, right? What's the y-coordinate? 8. Okay. So then this would be our relative maximum. Okay. This point we switch from decreasing to increasing. Okay. Approximately, what does that look like? 1 negative 4. Okay. Sure about the negative 4? Well, to be accurate, what could we do if we can't quite tell in the graph? We can plug it into our function, right? This would be 1 times 1 minus 2 times 1 plus 3. Negative 4. It is negative 4? Okay. Sometimes it's kind of hard because you can't really tell where the tick marks are right there. Okay. If you have your calculator, there's what's called a trace button where you can press trace, and if you plug in a value and press enter, it'll give you the coordinates that you're at. Okay, so if you have your calculator, you graph something, that trace button will trace the curve and give you coordinates that you want. Okay, but really, relative maximum, look for a high point in the graph switching from increasing to decreasing. Minimum, where does it switch from decreasing to increasing? Okay. Okay. Average rate of change. Okay. Have you heard this term before? Okay. Have you heard rate of change before? Yes. What is rate of change? Slope. Slope. Rate of change is slope. Okay. Now, average rate of change, we're still talking about a slope, but we're talking about the slope of a secant line. What is a secant line? It intersects. Good job, you read ahead. Okay, if you think back to geometry, a secant line went through a circle twice. Okay, so if we have a curve, a secant line would look like this. This red line is the secant line where it's intersecting twice. So the average rate of change, okay, we cannot determine a rate of change for a function that is not linear because it doesn't have slope, right? But we can look at the average rate of change, okay? We can pick 2 points on our curve that is not linear and find the slope between those 2 points, and that tells us the average rate of change as opposed to just the strict rate of change, okay? So anytime you're looking at the average rate of change, you have 2 points on a curve that's not linear, but you are finding the slope between those 2 points, okay? You recognize this equation right here, right? All it is slope, because f of x is always the same thing as y, right? y2 minus y1 over x2 minus x1, okay? So average rate of change still just means slope, but we're just finding it of the secant line, okay? Yeah?
Do you have to run the secant line through specific points, or can you?
It's going to tell you. For example, I want the average rate of change between these 2 points. Okay, here's our function, here's the 2 points. Okay, our function is not linear, right? Okay. So we need the slope, which means we need the coordinates, correct? They only gave us the x values, so what do we have to do? We need the y values. So f of 1 is what? 6? You agree? One minus 2 plus 8. F of 5 is what? 23? Okay. So we are looking at the coordinates 1, 7 and 5, 23. So if we want the average rate of change, we're finding the slope between those 2 points. So y minus y over x minus x. Okay. 23 minus 7, 5 minus 1. So our average rate of change is 4. Okay. Since it's positive, what does that mean about our function? Okay, so it's increasing from 1 to 5. Okay. Questions there? All you have to do is find the slope. Okay. All right. Last new thing. Even versus odd functions. Have you heard these terms before? Okay. Even and odd functions. These are functions that are special because they have certain physical and graphical and algebraic properties. Okay? An even function is special algebraically because of this. Really, I would just write this down right here. F of negative x is the same thing as f of x. Okay? What that means graphically is that we have symmetry about the y-axis. Okay? So an even function is special because the entire function is symmetrical about the y-axis. The y-axis is acting as a mirror for this function, okay? And we can prove it algebraically by showing that the function is the same thing as the function when you plug in a negative x. odd function. Okay? An odd function algebraically, please write this down. These algebraic properties are two that you will have to memorize. Okay? And an odd function has symmetry about the origin. Okay? You'll have to remember those symmetries as well. Okay? I will show you what it looks like to have symmetry about the origin. Right now that's hard to picture, I know, I will show you. Okay? Okay, so let's look at graphically what these look like. What does this have symmetry with respect to? The y-axis, so we call this what kind of a function? This is an even function. Okay? Here, this is an odd function. This is what symmetry about the origin looks like. If we fold it in half along the y-axis and then fold that in half along the x-axis, then we're going to match up. Okay? So this is what symmetry about the origin looks like. Yes?
Or isn't it basically a rotation?
Yes, you can think of it like that. It looks like a rotation. Good. So let's look at how you would prove it algebraically. Okay? Algebraically, let's look at what it looks like. You cannot plug in numbers. You cannot plug in numbers to test. You have to use the algebraic equations that I gave you. All right? So what does it mean to be an odd function? We're going to go backwards. What does it mean to be odd? F of negative x is the same as f negative f of x. Okay? F of negative x, what does that mean? We're plugging what in for x? A negative x, right? So f of negative x just means I'm plugging negative x in for x. Okay. So f of negative x is 4 times negative x squared minus 2. What does that reduce to? What's negative x squared? Okay. So we have 4x squared minus 2, right? All right. Now, is that the same as negative f of x? What does negative f of x mean? What do we do with our function? What?
Is that the same as a negative?
Yeah, we put a negative outside of our function. Okay. Which means we have negative 4x squared minus 2. Are those two equal?
Would the 2 become a positive?
Sorry, thank you. Sorry, thank you. Yes, it would. The 2 becomes a positive. Okay. Are these two the same? No. F of negative x is not the same thing as negative f of x. So we are not odd. Thank you. Okay. Now to be even, we want f of x to equal, or f of negative x to equal f of x. Correct? We already know what f of negative x is, correct? We already found that. F of negative x, we found already to be 4x squared minus 2. What's f of x? F of x is 4x squared minus 2. So since those are equal, we are even. Can a function be neither? Yes. So if you get them both to not work, don't panic. It's okay. It just means it's neither. But you need to check both. Okay? And you have to do it like I did with X's. You can't plug in numbers. Okay? All right. I'll let you go ahead and write down your homework.